by Chemical Bonding by Dania, Sutton, and Valeria. So there are 3 bonds, and they are metallic, ionic, and covalent. So the first one we're going to talk about is metallic bonding. So it is where 2 or more metal atoms bond by forming a sea of electrons with the valence electrons. And their role is basically just being a sea of electrons. So an example of that would be aluminum foil. All the electrons are stuck together. So their properties are, they're between 2 or more metal atoms. They're strong, but they're not as strong as ionic, and they're very conductive. Here's an example of metallic. So we're showing how it forms a sea of electrons, and you see how they all mix up together. The next example is, the next bond is covalent bonding, and it's a bond formed between 2 nonmetals by sharing electrons. And their role is that they're shared between at least 2 different atoms, and their properties are that they're very weak and they can't exist independently. And an example of covalent bonding is right here to show how the elements come together. The last bond is ionic bonding, and one thing to note is that they're always polar, which is great for the next thing we're going to talk about, which is the polarity scale. So they're the chemical bond where one atom loses an electron and another one gains, and their role is that they transfer from a cation and anion. And their properties are that they're between a metal and a non-metal. They're very strong. They have a high melting and boiling point. Here's an example of ionic bonds. So here we have sodium, and we show how they combine to form sodium with chlorine and can't remember what that's called. Next slide. Here are the diatomic elements, and they are covalent elements. So they're also called the deadly 7, and they are hydrogen, nitrogen, iodine, oxygen, fluorine, chlorine, and bromine. Now, polarity. So we have nonpolar and we have polar. So nonpolar is the equal sharing of electrons between atoms in a compound where no positive or negative poles exist. With polar, it's the sharing of electrons within a molecule. Positive and negative ends exist. So that's the difference between these 2. The positive and negative ends exist, whereas these ones don't in nonpolar. Now the electronegativity scale. So this just shows you how you can identify whether or not your combined elements are covalent, nonpolar, polar, ionic, and the way you find that out is you just use the difference between the elements, and you look at a scale, and from there you can decide what it's to be called. What's going to be called. Here we have bond angles. So there are 5 of them. We have linear, bent, trigonal, planar, trigonal pyramidal, and tetrahedral. So with linear, it has 180 degrees, it contains 2 or 3 atoms, it has no lone pairs, which is really important to note. And this is an example right here to show you what it looks like. For bent, it has 3 atoms, their bond angle is 104.5, and they have 2 lone pairs. Remember that. For trigonal planar, it has 4 atoms, no lone pairs, and a bond angle of 120. And the same goes for trigonal pyramidal. It has 4 atoms as well, but it has 1 lone pair instead of none, and it has a bond angle of 107.3. And lastly, with tetrahedral, you have 5 atoms, no lone pairs, and an angle of 109. This is the last slide of our video, and this just shows 3 different types of bonds. So hydrogen bonding, which is a very strong force between hydrogen and nitrogen and oxygen and fluorine. Now the dipole, which is between at least 2 polar molecules, and here's an example. The LDFS, which is a really long word,